Okay, here we go. Today, you guys are going to be working on Cartesian coordinate system. As you can see from the objectives, students will develop an understanding of the Cartesian coordinate system. Students will also explain the elements of those Cartesian coordinate system and characteristics of relations and functions. That'll make more sense once we get through with the notes. All right, so let's go ahead and get started here. First of all, we're going to label the parts of a Cartesian coordinate system. All right, and this is what our Cartesian coordinate system is. It's made up of some of the following things. It has an x-axis and a y-axis. So the first thing I want to do is go ahead and label where the x-axis and the y-axis are. So let's go ahead and do that. The x-axis is the axis that runs horizontally. That's this one right here. This is called the x-axis. And the y-axis is the one that goes up and down, vertical. So that would be this one over here. So we got the x-axis and the y-axis. Now, you'll notice here that those two axes cross each other. And when we do that, we end up with four parts, or quadrants. That's what we call these quadrants. You'll notice here we've got quadrant 1, 2, 3, and 4. So we're going to label those next. All right. So the first quadrant is located over here in the top right-hand corner. This is quadrant number 1. To the left of that is quadrant number 2. Right below that is quadrant number 3. And then this one down here is quadrant number 4. So the x-axis and the y-axis creates 4 parts, or what we call quadrants. So we start at the top right-hand corner, and then from there we just go counterclockwise. And some of you may know this already, and that's great. Now, origin. Where am I going to find the origin on this Cartesian coordinate system? Right in the middle. Okay, so this point right here is called the origin. So let's go ahead and label that right here. That is called the origin. And the coordinate for that origin, or the ordered pair for that point, is 0, 0. Let's go ahead and label that as well. 0, 0. Now, depending on what quadrant we're in, the x and y values could be positive or negative. It just depends on what quadrant we're in. So let's take a look at quadrant number 1. What we should know about quadrant number 1 is the x values are going to be positive, and the y values are also going to be positive. So both numbers that we have, the x and the y, are both positive numbers. That's in the first quadrant. Those are little plus signs. In quadrant number 2, what kind of x values am I going to have? Positive x values or negative x values?
Positive. Negative.
Negative. So I'm going to put a little minus sign here to represent those negative x values. The y values, however, are going to be what kind?
Positive.
Positive. So if I give you a negative x and a positive y, you should automatically know that that falls into the second quadrant. Okay. Third quadrant, what kind of numbers am I going to have there?
Negative and negative.
Negative and negative. The x is negative, so is the y.
Positive and negative.
And the last one, quadrant number 4, our x value is positive, and the y value is negative. And we're going to get some questions like that here in a minute. Okay? So again, x-axis, y-axis. The origin is where those two axes intersect, and it creates 4 parts called the quadrants. Quadrant 1, 2, 3, and 4. All right, does that sound familiar? Y'all talked about this before. That's not totally new to you guys. All right, let's keep going here. The blank is used to graph relations between quantities. The blank is used. Well, we just took a look at that. It's called the Cartesian coordinate system. The title of your paper. The Cartesian coordinate system is used to graph relations between 2 quantities. We'll talk about that word relations a little bit more here in a minute. But again, the Cartesian coordinate system. That's that piece of graph paper that you guys work with. It says it's composed of 2 number lines called the x-axis and y-axis, which we just saw. The two number lines divide the plane into 4 quadrants. A blank for a blank is written as x and y in parentheses. What do you call that thing right there? What do you call this thing?
Axis.
What is that thing called? Well, let me give you an example. What if I give you this thing right here? What is that thing called?
Coordinates.
A point, a coordinate, another name, an ordered pair. All right, very good. So this is called a point or an ordered pair. And when we write a point and an ordered pair, or an ordered pair, it's written so that we have the x value first, the y value second. Notice that we can also write it as x, comma, f of x. That's another way of writing it. That's a good question. Notice right here. Right here it says that another way we can write the y is by using f of x. So when you see f of x, it represents the same thing as the y. They're kind of the same thing. So here we're given a set of ordered pairs. -2, 3, that's one ordered pair. 0, 0, that's another ordered pair. 2, -5, that's another ordered pair. So this is a set of ordered pairs. So the next part here says blank can be graphed as a point or a set of points. We call this a relation. A relation can be graphed as a point or a set of points. So at the end of class, one of the questions I'm going to ask you guys is, what's a relation? And basically what I want you to remember is, a relation is a set of points. Or we can also say that it's a set of ordered pairs, because if you don't say points, ordered pairs, they mean the same thing. So at the end of class, when I ask you, what's a relation, you're going to say set of ordered pairs. Or we can also say a set of points. So either one is accepted. So again, relation is a set of points or a set of ordered pairs. As a matter of fact, if you look over here, guys, I have something called a word wall. That word relation comes up quite a bit. So if you ever forget, right here it says relation is a set of ordered pairs or a set of points. All right, let's keep going here. For the set of ordered pairs in which the or the set of ordered pairs in which quadrant would each point be located? So for this first ordered pair, -2, 3, where would I find that one? In which quadrant?
Quadrant 2.
Why would it be in quadrant 2?
Negative and positive.
So there's a negative number and then a positive number, which puts it into quadrant number 2. So go ahead and write that down. Because it has a negative x value and a positive y value, that would put it in quadrant number 2. What about the ordered pair 0, 0? What quadrant would that one fall into?
Origin.
That's right. That's a trick question, guys. It doesn't actually fall into either of the quadrants. It happens to be the origin. It's at the intersection of the x and the y axis. Don't be fooled. It's not in the first quadrant. It's not in the second. It's not in the third. It's not in the fourth. It's the origin. It's right in the middle. What about the next order pair? 2, -5. Where am I going to find that? 4. Okay. Quadrant 4. And the reason we're going to find that one in quadrant 4 is because we have a positive x value and a negative y value.
Do we have to write quadrant?
No, as long as you put the number, you're okay. And then one more here, the order pair 0, 3. What quadrant is that one in? Oh.
Origin.
What?
The y-axis.
There we go. It doesn't fall in either quadrant, guys. This one happens to fall on top of an axis. Which axis? The x-axis or the y-axis?
Y.
Y.
Y-axis.
X goes first and
Y-axis.
Oh, get
So it's
that.
not in quadrant 1, it's not in quadrant 2, it's not in quadrant 3. It falls right on top of the line. And the line it falls on top of is the y-axis. So a lot of terminology here. A lot of terminology. All right, let's keep going. The next one says the blank of the relationship is the set of permissible x values. Now remember, I just told you what a relation was. It's a set of points or a set of ordered pairs. All right. So the x values. We got another name for the x values. We call that the domain. Domain.
Oh, we're learning it.
Domain. Yeah, some of this stuff should sound familiar. We kind of overlap with some of the things that you learned last year. Domain. Now you'll notice this is another very important word. As a matter of fact, if you look at the word wall again, notice how that word domain is also over here. Notice domain is a set of x values, or the x
Did
value.
you teach her last year?
What's that?
Did you teach her last
I
year?
was here last year, yeah.
What did you teach, algebra 2?
Algebra 2. All right, so if we look here, again, domain is the x values. The notation for a domain is D with a colon, and then negative 2, 0, 2 in those little brackets there. Domain can be either continuous or discrete. And we'll talk about those two words here in a minute, continuous and discrete. All right, next blank. Blank data are individual points that would not be connected when correct. We call this discrete. Discrete are individual points. Points that are not connected. Points that are not connected. Discrete. That's another important word, and I'm probably going to have to add that one to my word wall. It's not there yet, but I think I'm going to have to add that. Discrete. Individual points are points that are not connected. As a matter of fact, I want you to highlight that point so that we don't forget it. Discrete points are not connected. The next blank we have, blank data are infinite number of points that are connected. Points that are connected. This time we call that continuous. Continuous. And I want you to do the same thing for me. I want you to circle that they are connected. That's the difference between discrete and continuous. One are points that are connected, the other is points that are not connected. Discrete and continuous. Discrete and continuous. All right, the next one here, the blank of a relation is a set of permissible y values. Now, domain are the x values. Domain are the x values. So what do we call the y value?
Range.
The range. There it is. Range. We call the range the y values. And that one I do have on my work one. So if you ever forget, it's over there in blue. Range is the y value. So we got domain is x, range is y. Discrete, the points are not connected. Continuous, the points are connected.
With range, do we circle y-axis and the y value?
Yes, that wouldn't be a bad idea. Y value. As a matter of fact, let's go to domain and make sure we circle the x value. That way you don't have to remember every little thing that's written down there. You can highlight the key important parts. All right, let's go to the next page here.
We have to do this on our own.
Not yet. Not yet. Next it says here, relations in which each element of the domain is paired with exactly one element of the range are called blank. First of all, this word relation. I've already told you what the word relation means. What did I say relation was? It's a set of points, or a set of ordered pairs. Okay. So we're looking at a set of ordered pairs where the domain, what did we say domain was again? X. So I'm going to put a little X so I don't forget domain is X. Is paired with exactly one element of the range. What did we say range was?
Y-axis.
Y. So again, we're looking for a set of ordered pairs where each X is paired with exactly one Y. Set of ordered pairs where each X is paired with exactly one Y. We call that a function. We call that a function. That's another important one. If you look over there at the word wall, it's in green. Function. A function is a set of ordered pairs where each X is paired with exactly one Y. Okay, right below that, if a set of data is a function, each X value is paired with a unique Y value, which is basically saying the same thing I just said there. In other words, the X's don't repeat. The X's don't repeat. each x value is paired with a unique y value, or we can say the x's don't repeat. So in order to be a function, x's cannot be repeated.
Like, what do you mean, X, like, as in the numbers on the X axis?
If I give you a set of ordered pairs, I can't use the same x twice. I can only use it once.
Oh,
Okay? And I'll give you some specific examples a little bit later. Next one says, if a set of data is a function, a vertical line will cross the graph of the data in only one point. In only one
oh, I messed up. Put it on
point. A
top.
vertical line will cross the graph of data
Put it in
in
there,
only
fine.
one point. So I'm throwing a lot of terminology out there, and I'm going to be using that throughout the year. I know sometimes in junior high they may say, what's the x, what's the y, but now instead of using the words x and y, I'm going to be using domain and range. I expect you to know they mean the same thing. Right? Domain is x, range is y.
Is it just complicated?
All right, let me see if we're paying attention. Relation. Without looking at your notes, what did we say relation was?
Set of
Point.
Set of points for a set of
Ordered
ordered pairs, right? Relation is a set of points for a set of ordered pairs. Domain, what was that one?
X,
The x's, the range is the
Y.
y values. Two other words here, discrete and continuous. The word discrete, what is that?
Not connected.
Points that are not connected. Continuous means
Points that are
that are
connected.
connected. Function. Function is a relation or a set of ordered pairs where the x's do not repeat. X's do not repeat in a function. Okay, let's keep going here. All right. Down here at the bottom, it says if the y values increase as the x values increase, the function is blank. If the y values increase as the x values increase, the function is blank. Increasing. In other words, as the x values are getting bigger and the y values are also getting bigger, then our graph is increasing. And we saw this the other day in one of the activities that we did.
Oh,
As the x
yeah.
values get bigger and the y values get bigger, we call that an increase. Which means the next one there, if the y values decrease as the x values increase, this function is said to do what? Increase. What's the opposite of increase?
Decreasing.
Decrease. So this time, as the x's are getting bigger, the y values are getting smaller, and if that happens, then our graph is decreasing. Decrease. So, here's what I want to do.
Is it on?
I'm going to go down the row, and I'm going to ask you one of our key terms. All right? It could be, let me just do this real quick here. I could ask you what's a relation, and what is a relation? A set of points or ordered pairs, that's a relation. I could ask you what's domain, what's domain? X. I could ask you what's range?
Y.
I could ask you what's discrete? Points that are not connected. I could ask you what's continuous?
Points that are
Points
connected.
that are connected. And I could also ask you what is a function. And that's going to be the hardest one. A function is
Set of data
a set of ordered pairs
where
where the x's
do not
do
repeat.
not repeat. That's perfect. That's what I want to hear. A set of ordered pairs where the x's do not repeat. I'm gonna ask you one of those six. All right? Ready?
I said it.
Domain.
Uh-huh.
What's domain?
No.
Domain. Guys, if I ask you, you're going to have to give me an answer. And if you don't give me an answer, I'm going to skip you and then I'm going to come right back to you. So, you better be ready. Range. Y values. Relation. relation. Make sure you pay attention because by the time I get to you, you're hearing it quite a bit. So, what's the relation? Set of ordered pairs. Domain.
Like that? Like you did this?
Not x-axis, guys. It's just the x values. Okay. Domain is the x values. Range.
Oh, I wanted that one.
Aw.
I get that one?
Domain is the x values. Range is the y values. Relation. Set of ordered pairs. Domain.
X value.
X values. Discrete. Discrete.
It's when it doesn't.
Doesn't connect. Continuous. Point two. Where are you going?
So much trash.
No, we don't get up there in class and throw trash. You just stay seated and you can take care of it. Domain.
Can Adrian?
X value. Range. Y value. Relation. Set of ordered pairs. Discrete. Discrete. Points that are not connected. Continuous. Points that are connected. Domain. X values. Range. Domain was X values. Range is Y values. Relation. Relation. Set of ordered pairs. And the last one here, discrete. Points that are not connected. Very good. Now, guys, here in a minute, I'm going to come back to you again, and I'm going to ask you the same questions. As a matter of fact, your ticket out of here today is to answer one of those questions. We're going to line up. If you answer right, you're out the door. If you answer wrong, you got to go back to the other line. So, I'm going to keep coming back to you and asking you. We're going to line up a little bit early. I'll get out of here a little early, but we're going to line up a little bit early. All right, so here's the deal. Here's the deal, guys. The next part. Remember, I said I was going to do some of the notes with you, and then you're going to have to answer some questions. All right, so be ready. I'm going to ask you some questions here in a minute. I'm going to go ahead and help you out with this first one here. Number one, connections. This is going to go back to two of the activities that we already done, or two of the worksheets. One of them is that miles and intersections. That's the one I asked you. How far do you live from the school? And how many intersections do you go through? And the other one refers to the one you did yesterday on the burning calories. So we're going to go back to these two activities. Hopefully you still remember those two. So here we go. The first one. Remember that a relation between two quantities is a set of ordered pairs. Okay. Relation is a set of ordered pairs. Get that in your head. A relation is a set of ordered pairs. Now that you know that, part A here says, in miles and intersection, is there a relation? Is there a relation
No.
in miles and intersection?
No.
Listen to my question.
Yes.
Oh, yes.
Relation is a set of
Yeah.
points or ordered pairs. Did we have a set of points or ordered pairs in miles and did we?
Yes.
Yes, we did. Were there any kind of a pattern in those points?
No.
No, but did we have ordered pairs?
Yes.
Sure we did.
So there's a yes,
So,
yes, ordered pairs.
yes.
No.
Yes, we did have a relation. And why do we have that relation? Because we had a set of ordered pairs.
Do we just put that? We had a set
Yes,
of ordered pairs.
we had a set of ordered pairs. If you want to shorten it and say we had a set of ordered pairs, you can do that. So yes, there was a relation. Anytime we have a set of ordered pairs, guys, that's called a relation. We had a set of ordered pairs.
Oh.
So miles of intersection was a relation. We had a set of ordered pairs. The next one, B, in burning calories, is there a relation?
Yes.
Did we have a set of ordered pairs in the activity that we did yesterday, burning calories?
Yes, we did.
Yes, we did. Was there a pattern in that?
Yes.
Yes, there was. Anytime we have a set of ordered pairs, it's called a relation. Both of these activities have ordered
So
pairs.
we just write the same thing as we did on
Yep.
first?
Yep. This is a relation because it has a set of ordered pairs. Now, don't worry about part C. What we're going to do is we're going to turn the page here, and now you're going to answer a couple of questions for me. And you're going to do this completely on your own, with no help from your buddy sitting next to you, okay? On the back there, you have 3 through 8. These are the questions that I want you to circle. These are the ones you're going to answer for. You're going to answer number 3, 5, 6, 7, and 8. So you don't have to do number 2 or number 4. 3, 5, 6, 7, and 8. Answer those questions for me. Answer those questions for me. You have to think back, and if you can't remember that, you can turn the page and find burning calories, and you can find the miles and intercepts. Answer those questions for me.
What's dependent variables? I don't know.